Okay, so I think we got a good room full of people. So thank you for coming. We're going to take this session and we're going to speak about DevOps, DevSecOps. I'm Alistair Anderson. I'm from Cyber-Ark. We specifically work on privilege. So let's dive in and we'll take a look at exactly some of the new challenges that you face with privileged accounts in the cloud. So just a quick introduction to Cyber-Ark, and then we'll dive into some of the more general best practices around how we can deal with privilege in the cloud. So Cyber-Ark, we're specifically looking at the problem of privilege. We've been doing so for many years around privileged accounts on-premise. And obviously, a lot of you are going to be looking at, hybrid environments in the cloud, and the problem of privilege still exists, and it changes. We had a recent acquisition. We're looking at a team, a community called Conjure, who develop solutions for providing secrets and privilege within cloud environments, which are specifically dedicated to that. So we have a very strong foothold and community there that you can work with, that are open. And you can participate. It's open source. So we'll talk a little bit about the solutions that we provide in that. The first thing I want to do is talk about what changes when we move to the cloud. So very, very simplistically looking, this is the real shift that we see. Whereas before we've helped a lot of customers and large enterprises in the world deal with privilege and how they can manage that in an enterprise. So you might be looking at dealing with accounts like administrator accounts, root accounts, and this in the traditional data center. An attacker would need to compromise each system individually. So it's a lot of work. Where you move things into the cloud, you're actually creating instances. Like you see up here, you get instances where you're creating consoles that can really access the entire data center. So you're actually creating user profiles that have much more privilege. So they're much higher risk, and we want to protect them. So specifically things like your access to consoles, so the console into OpenStack, the console into your cloud providers, into your virtual infrastructure has great power. You can bring up and you can take down an entire infrastructure based on that. So there's a lot more risks, and we're seeing this. This is a very simplistic view. We'll get into the details, but this is basically what's happening. We're seeing like a concentration of privilege, and whether that's for a human operator, so someone who's actually putting things into the cloud and moving this, or whether you're doing automation. If you're doing automation and you have tools like Jenkins, Ansible, Puppet, all these tools that are in there, you've got privilege there, and if you can attack those, you can compromise everything underneath that. Okay, one very quick word on on DevOps in particular. I know here we're talking about cloud and a little bit about DevOps. Here we've seen from the start of the conference there's a huge adoption with moving to the cloud and DevOps. The one I'm going to point out on the right here is to do with security. So we're seeing security being a typical blocker into this. So while your dev teams and DevOps are very quick at getting things working, security is often added on at the end there. So we're looking really at creating something for DevSecOps where we can build in and automate security into the pipeline. So we're providing solutions in that space. Looking specifically at the change, we do have differences between the traditional monolithic on the left-hand side, microservices on the right. So you're probably looking at virtualization in containers. And as you can see, we're creating more and more instances. And really, the way I see this from a privilege point of view is this is more and more instances of credentials and passwords out there. So where before, you might have had on the left-hand side, you have a server that has, a password built in. You might be in a configuration file. You're going to need to distribute that into all of these systems, into these containers, and that can be a real problem and a real challenge to actually just manage. A lot of the developers and operations right now are saving things like passwords and credentials in configuration files. They've got them, it could be in YAML files, it can be in configuration files, and they might try to secure them in some way. But the truth is we've got shared passwords, and that shared password problem still exists in the cloud. Once we distribute them, they become a real problem to then change. So as well as the quantity, just the sheer number of instances that we need to actually manage, we also have a whole new as we see it, an IT department. So the people who are actually making changes is no longer people, but we go and enable applications. So we enable our configuration management like Puppet, Chef, and Ansible that I mentioned before. So these are the powerful operators in your new infrastructure. And we really give these guys the keys to the kingdom. And it's very difficult to manage. Each of these typically becomes a security island. So everyone has their own method of storing secrets. They have their own method of authentication and authorization. And it really becomes problematic when you have lots of different tools that are also moving around. The way an attacker sees this, let me skip through these. The way an attacker sees this is that once the pipeline's all automated, really as long as you're following the rules, then no one's really going to be looking at what's going on behind the scenes. It's quite difficult. Once a shared password's out there, it's very difficult to revoke, change, and remove. They're going to be looking for keys to steal. They love the fact that we've got shared over-provisioned secrets. So once they're out there, they're quite static. Once you've embedded it into an application, you'll find it quite difficult to change. And really, they just find a whole new tool set of how they can actually compromise your assets in the cloud. So that's the way they see it. I want to give you some examples of how this is being compromised already. So we work a lot with customers who've had breaches and different examples here, customers who want to secure their environments. If we look from things like the developer side, we see credentials in the cloud, in GitHub, posted publicly. We've seen that. So even when they're sharing things like configuration files, they want to see, okay, this doesn't work, I want to see how to fix it. They share them between developers, between operations, and often those configuration files contain passwords. And there's a couple of occasions, we'll show you them now, where that's ended up on the internet. Your actual dev teams themselves who have access to these consoles, and typically once you have access to something like a configuration management tool, once you're in, you can basically do almost everything in these kind of tools. And compromising the credentials of an actual developer would let you do that as well. And there's other ways to compromise the whole workflow from DevOps. So once you have access to something like the whole automation workflow, you could insert your own malware into that flow and have it deployed onto many servers. So automation can actually help an attacker. And it really applies through all your different infrastructures. Here we talk OpenStack, but it could be anywhere. Okay, so this is a good example. This is a real example we've seen where actually keys. So this is access keys, API keys that are stored actually in a configuration file. Clear text, so anyone who can access this configuration management server can access the keys. It's an AWS key, so not a problem for us here, but the truth is it applies to all cloud infrastructures where you're using keys to access and provision. So you want to create servers, delete servers. These keys will let you do that. And even worse, they're making their way into public domain. Let me just show you very quickly, and then we'll talk about some of the solutions to this. Some of the examples we've seen. So we saw back last year, we saw Vine actually had on Docker Hub. So they had Docker containers that contained all of their keys publicly available. Okay, so this is hard-coded credentials inside containers and more. So we really want to be able to get those hard-coded credentials out of configuration files, out of the containers. Uber again, they had a database compromise, and the keys to connect to that database were made available publicly. And then even just last week, we had Viacom. Don't know if any of you had picked up on that one. Again, they had basically entire backups set in the cloud, and they were saved to a cloud storage that was publicly available. And inside their backups, they have keys to their entire infrastructure. So it's keys to databases, keys to their console, keys to the cloud access, everything. Now, Viacom were quite quick to respond. They were advised, and within a few hours, they managed to actually make the changes. But often, you need to be able to think how quickly could you change keys if you need to. If you needed to, if you realize that it had been compromised, how quickly can you change them? Okay, so we'll just summarize the attack vectors, and we'll take a look at some of the solutions now. So essentially, within the cloud, we've got this explosion of short-lived entities. They all require keys. They all require secrets and identities to operate. we can't hard code them in. We can't have these things be created with keys already built in. Or we'll see what happened in Vine. Someone could just steal that instance and they can recreate your entire environment on their own land. We got the privileged automation tools that are doing the work of sysadmins. So they've become extremely powerful. And then finally, we've got these cloud and DevOps workflows, which can actually represent a new risk as well. So attackers can utilize these flows to distribute their own malware. Okay, so this is the DevOps flow that we want to secure. Ideally, how do we do this? So we need to be able to authenticate and authorize everything in this flow. And if we got shared secrets, that's very difficult to do. For the people, we've been doing that for many years. We know we can authenticate someone with a password, multi-factor, and we're good. It could be biometrics, whatever you want. But when it comes to these applications, we need to give them credentials. We want to be able to authenticate them and make sure that it's your instance of that's running, and that we have the audit and accountability around that. So when you run your reporting, you say what privileged activity was executed in the last 30 days. We don't just have the people who logged in, but we also know what the applications were doing. So once they're out there, they should still be reporting back in and telling us when they're authenticating. The biggest challenge in doing this, and this is the one that we're looking to resolve, is machine identity. Okay, so we don't want to have a machine or a container or an application that has a static credential built into the code. We want to be able to have this container, whatever it might be, spin up and then give it an identity. It's a challenge to do. The way that we do it at Cyber-Ark, and especially with Conjure, we're actually able to be able to extend a chain of trust. So essentially we can give privileges to something like a configuration management system. So we could give privileges to Jenkins, for example, and Jenkins can then go and create these machine identities, and individually be able to identify every container. Okay, so it's extending the chain trust. Essentially, at the top of this chain, the top of this hierarchy, somebody needs to kick off this. So there's always a person behind this. We talk a lot about automation, and even the people who want to automate everything. Once the pipeline is automated, you still you log in. There's still a console. There's still a person who kicks off these actions. Whether it's to deploy a new version of the software or to make changes, there's still a person who kicks this off. So we leverage that person's authentication and have this chain of trust essentially, so that what you can do is remove the password and the secrets and the keys from configuration files and the source code. Okay. So human users, here there's still a challenge here. The main problem in the cloud is that typically there's some, we don't have as good role-based access control implemented within these tools, and it's because the tool sets are so many. Because we showed you before how many tools there were in the cloud, every single one is going to make you authenticate and authorize, and we can have some confusion, So we're looking to have some kind of standardization around making sure we know who has access to what, and should they have access to it. You need to implement least privilege. And I would say that certainly to do that, typically a developer might have too much access today. So would a developer have access to the secrets and the passwords that containers in your applications use? Probably yes, today. So they would actually see those passwords and they could use them. So the way that we look to resolve this is how the attackers see our code. This is from Puppet, an example. We can see username and password in the code. We can resolve it by using an API call. We can call this is through our REST API. We can get the secret from our credential vault. Okay, so we can, and as the application does this, we're able to audit that. We're able to authenticate it, and we use the chain of trust to authenticate it. So best thing is we got no secrets in the source code anymore, and that all ties back. If you can see, at the top you've got a vault, and this could be built in any such way that you want. From Cyber-Ark side, we give you a lot of tools that are able to reach into things like Jenkins, Ansible, and Chef to already help you do this. So you don't need to build your own custom code to do this. It's something that can be used on-premise, hybrid, in the cloud, and we have various solutions for helping you remove those credentials. Let me just get back. Okay. Bottom line is that you get visibility. So you're going to have, from the fact that everything within the solution that offers from Cyber-Ark is done in code. So it fits into the pipeline. You can actually automate the fetching of secrets, pushing secrets, and generating new ones. So that can all be automated, but you do have the visibility of what's going on as well. So here we can see exactly who's retrieving credentials, what our containers are doing, what our applications are doing within the business. Just skip through here. Okay, so what I wanted to talk about here is best practice around this, where we really need to apply this in the cloud. So something that you can look at doing. You can choose your tools to do this. This is the best way to do it. Though we're looking at secure the management console, and securing the management console typically means we're talking about those the users who are logging in who are highly privileged. So you could look at putting them under the controls of something like Cyber-Ark, which would be able to manage their credentials, their passwords, and their access. So you have all video recordings and access to everything that's done within the management console. It's highly sensitive. Another way is obviously doing multi-factor authentication. So if you have users log into your admin console, make sure you're doing multi-factor as they go in there for your developers and everything else. Secure your cloud infrastructure. So there's the shared responsibility model often. So depending on which part of that cloud asset you own, you might no longer be responsible for hardware, operating system, other things anymore. So there's part of that. But the part that you are responsible for, you absolutely need to secure that. So the keys to accessing servers at the level of the operating system and otherwise, you need to be able to put that into a flow, and again, put them into a vault and have control over who's accessing those credentials. API keys, again, they can be taken out of configuration files and source code, put them into a vault. Then we've got the admin consoles and tools. So if we went back and looked at the tools that we talked about before for provisioning and for automating the creation and everything of containers, we need to be able to secure the credentials that are managed there. And then finally, inside the code itself, removing those credentials. Let me show you some examples of scalability and integrations that we do. So we're looking here for the scalability. On as far as infrastructure goes, these kind of tools can apply to any infrastructure. But more specifically, apart from just providing an API to get secrets and to push secrets, we also have specific integrations. So we partner directly with Puppet, for example, where there are specific plugins there that are pre-built. There's a community that builds and maintains these. So you actually have ways of removing credentials from your configurations in Puppet, in Jenkins, Ansible, Chef, all these, for example, without creating something new for yourself. This is a very easy way, and if you are using these tools, it's worthwhile reviewing and understanding where you're using secrets and how they're being managed right now. Okay, so you really need to get visibility of the use of these. I'll show you this example. I think is very useful to understand how we can solve the underlying problem. So here, in this example, we've got two environments. We've got a test or staging environment on the left, and production on the right. We've got lots of servers out there that are agents from Puppet, and this is the chain of trust. So as an operator, I can log in. I can provide the Puppet master with credentials, so I can provide it an identity specifically, and then that Puppet master is able to create on the fly. So in real time, it can create identities for all of our agents out here, and it can then differentiate based on policy. So we can decide what applications go into tests, what applications go into production and get production keys. And this gives us a layer of abstraction so that we can then make the passwords dynamic. So if we look at the starting point, we looked at a situation where our passwords are static, they're in the source code, and they're very difficult to change. Here we're using this chain of trust to give identities to each of these, that then go and fetch a secret or a password, and that password can then rotate, it can change. So as a kill switch, you can very easily decide, okay, this password's been compromised, you can change it, and you can identify every single agent and container you have out there. If you follow the flow, essentially your puppet masters is being able to push out configuration to these targets, and they'll call back in and get an identity. So as they're created, they'll get their identity, and typically we're looking at these lasting in the DevOps world for really a number of hours, days maximum. Whereas back when we were looking at virtualization, we had servers that would be they would be there for months, for potentially years. So that's our example in Puppet. Very similar for Chef. Again, we can differentiate, and we're going to get the accountability and audit on all of this. And I just want to show you what that looks like in the end. So once you've got all this plugged in, you're starting to get visibility on things. Like you can see on the left here, we've got Ansible, we've got Jenkins calling in and exactly which secrets they're using. So you've got an audit trail, and this audit trail is then made available it's secured in a vault and made available for real-time analysis. So then you, apart from just pushing applications out with credentials and not knowing what they're doing anymore, you get visibility every time they call in, every time there's a new instance, you can see it here. And again, it makes those secrets dynamic. Getting them out of the source code and getting them fetched every time makes them dynamic, and you get a chance to automate the change. I'll give you one example of, we got Machine Zone here as a customer who's using Cyber-Ark Conjure specifically to provide secrets to the entire infrastructure. It's a great example of the implementation of DevOps, because they're basically recreating their entire data center every night. So they do up to, I think it's 2 million secrets reads per minute. So when they go and recreate everything, they have a really high impact, and they're giving identities to every single container that they have out there. So there's a high load, it's highly scalable, highly flexible, and they're using that for API keys, their database passwords, and to distribute all their secrets. Okay, so it's something absolutely scalable and built for the DevOps environment. Okay, so last slide, we'll just to summarize. We're looking at centralizing secrets and being able to help you manage them. We integrate with these continuous integration tools. So like I said, we have specific plugins for Puppet, Chef, and Ansible. And all of this builds into existing flows within enterprise. This is the most important part, is that the security teams already know these tools. They can get approved, so you can get certifications for your compliance side and everything else. And most importantly, it's open source, so you can try it today. There's a great community out there. Absolutely try it out, it's free. I'll leave you some references here. Okay, thank you very much.